Welcome to this class. In this class, we will discuss fuzzy inference systems, or other way also we can call it as a fuzzy models, followed by the demo on the design of fuzzy logic controller. Okay. So basically, there are three different types of fuzzy models, or three different types of fuzzy inference systems. First is called Mamdani fuzzy model or fuzzy inference system. Second is Sugeno fuzzy model or Sugeno fuzzy inference system, and third is Tsukamoto fuzzy model or Tsukamoto fuzzy inference system. Already we have discussed on Mamdani fuzzy model. So next we have to discuss the Sugeno and Tsukamoto. So in this first we will just have a short discussion on Mamdani, Sugeno and then Tsukamoto. Okay. So first let us review on the Mamdani fuzzy model or Mamdani fuzzy inference system. So for that, suppose I have two antecedents, one consequence and two rules. We are familiar now how to form the rules, how to obtain the consequence, etc. So first rule says that suppose if some variable, any variable, let's say temperature, pressure, flow, etc. Let me call that variable is x. If the temperature is A1, that A1 I can call it as a fuzzy set, and y is B1 or B1 bar, then I will say that other variable, that is z, is some fuzzy set expressed by C1 bar. Okay, so x may be any variable which you would like to control, y is also any variable which you would like to have the modification, and correspondingly z is other variable which will act as a output. Okay, so I can also say if temperature is this one and pressure is this much, then z will be, or flow will be this much. Okay, so I can say that x is my temperature variable, y is my pressure variable, and z may be your flow variable. Okay, or you can say in terms of this is my voltage, this is my current, then that much will be my modulation index or pulse width, like that. Okay, then rule 2 says that if same thing x, some same variable, you can say temperature, is represented by a different fuzzy set called A2 bar, and the same variable is represented by other fuzzy set called B2 bar, then its output is something represented by other variable, other fuzzy set called C2 bar, because we know how to form the hedges, if hedges or descriptors. Say if I would like to express temperature in terms of hedges, I can say that very cold or cold. Okay, or I can say warm or very warm, something like this. Okay, or I can say temperature is very low, low, medium, like this. Okay, so this hedges or descriptors are nothing but A1 bar, B1 bar, some Z is C1 bar, like this, and that we know how to form in terms of fuzzy set, or how to represent in terms of using membership function. Okay, so suppose let me represent that using, let's say, Gaussian membership function. We can represent using triangular also or trapezoidal also. Okay, so this is suppose variable x, and this is my membership function. So let me represent with Gaussian something like this, which will represent one of the edge, maybe very low, etc., or low medium, it's like this, suppose, and this represented with a1 bar. Similarly, next variable represented by this fuzzy set, let me call this is b1 bar, represented by Gaussian. Okay, and its output is something like this, is z, and also let me represent with same Gaussian form. Okay, so this let me call mu3. This is one rule has been formed. If x is a1 bar, y is b1 bar, then some z is c1 bar. Now the next descriptor, suppose this is a1 bar is low, then next I can say very low. So let me represent that descriptor is something like this, call it is a2 bar, say some form is mu4. Okay, x is universe of discourse here, y is also variable or universe of discourse, and that has been represented by like this, suppose, and its consequence or output is like this, which is, or let me represent with something like this. Okay, now I would like to evaluate this rule for some, let's say some x1. So let me introduce some x1 here, that says some x2, some y1 here, and some y2. Okay, so suppose these are my changes which has been introduced in the system. So correspondingly now I would like to know its output. Remember that changes may be same or may be different. Okay, so suppose that change x1 is here, y1 is here, and we know how to form using max-min composition, so that you do intersection. Okay, and then select the maximum. Similarly, for to do the intersection, select the maximum. So from that again, say this is w1 and w2, from that select the minimum. So this much will be my resultant consequence if there is a corresponding change x1 and y1 like this. Similarly, say these are my changes x2 and y2. So again use the max-min composition and find out this is my maximum, say something like this. Okay, so this is the projection using max-min. Similarly, this is the projection using max-min. Let me represent with w3 w4 and select the minimum from it, so which will be clipped on this c2 bar. Okay, and these rules will be added or aggravated. So what will be the augmented membership function or resultant consequence? It will be the addition of this and this, so something like this, and say this is more than this. Okay, so let me call this is w5 and this is w6, and assume that w5 value is greater than w6. So here something like this I can write. Similarly here also. Okay, so this is my, say c1 dash, and this is c2 dash. Okay, and from that I should be able to defuzify this value, and we know the defuzzification methods. With that we can find out the defuzzified form. Okay, so the same thing I can represent using triangular membership function also. So instead of Gaussian, I can make it triangular. This is also triangular. Okay, so with this, what you will get it some triangular way. Okay, and we know that how to defuzzify it. Okay, so this is the Mamdani model as already we discussed, but just have a review on it. Then next model we'll see the Sugeno method, and it has been suggested around in 1985. So let us see what Sugeno said. So here in Mamdani method, what we have seen that all the antecedent and consequence both are in fuzzy form. But in Sugeno, what is the condition? In Sugeno, the condition is that your antecedents or the inputs will be in fuzzy form, but your consequent or your output will be in crisp form. Okay, so that crisp form means some you can represent with some equation, that is will be z is equal to, it's a function of f and of f of xy, so you can write as a straight line also ax plus by plus some form, that is r. That way also you can represent the crisp function or real function, and which will be suggested by Sugeno. So it's a polynomial in terms of input x and y, but it can be general also. When your f of xy will be constant, then that inference system will be a zero order system, which looks like your Mamdani. Okay, when f of xy will be linear, then that system will be your first order system. When f of xy represented with quadratic form, then that will be a second order system, like this. Okay, so let us see geometrically how it can be said. If x is a1, say one rule is that y is b1 bar, then here consequence not should be in fuzzy form, but it should be in crisp form. So I can write z will be equal to f of xy. Similarly, if x is a2 bar and y is b2 bar, then your z will be something, let's say f of x2 and y2, or let's say f of xy. So this is z1 and let me call z2, or let me call z as it is. I will call this is f1 and this is f2. Okay, which will indicate the different consequence for the different rules. And graphically, how can we say, let's say like this, say this x, suppose this is my a1 bar, y, this is my a2 bar. So your z will not be in fuzzified form, but it will be some function f1, and let me represent that function is something like this. Okay, so which will be your z will be equal to, say this is something a1x plus b1y plus c1. Okay, similarly next rule says that if it is like this, this y something like this, a1, this not a2 but this is b1 bar, this is your a2 bar, this is b2 bar, and your output will not be in fuzzified form but it is in crisp form or real function, something like this, which is a linear. Okay, so now let us take it some change. So suppose there is a change, now I'll take it the same change. So this is my suppose x1, and this is y1. Suppose this is your change, no? Okay, let me introduce a change like this. Now what is to be done? Use the max min composition. So you do this projection, that is intersection, select max as a projection and then take it the intersection from it. So you will get this point, let me call z1. Similarly here also you will get minimum from it, which is this. So this let me call z2. So suppose z1 is represented as p1 your x1 plus p2 into y1. Similarly z2 let me represent with some p2 into, say this is same x1 and y1, so I can write p2 x1, not p2 but p3 x1 p4 y1. Okay, so with this I will get one value, let me call alpha 1, second value I will call, let me call it as alpha 2. Okay, this one is my alpha 1 and this is my alpha 2. Okay, this z1 has been obtained using this. Okay, so once I know z1 I will be able to know what is alpha 1, because alpha 1 already I know it. Similarly alpha 2 also I have obtained it. Okay, and from that alpha 1 I got z1 and I got z2. Now what should I take it as a resultant? So always if you have a two values and if you would like to combine into one form, so always z asterisk will be in the weighted average form. Okay, so that can be represented as alpha 1 z1 plus alpha 2 z2 divided by alpha 1 plus alpha 2. Okay, so with this at least accuracy will be improved than that of taking the mean also you can take z1 plus z2 divided by 2, but instead of that if you will take it the weighted average output, it will give much accurate result than that of the mean or arithmetic mean form. Next model called Sakamoto Fuzzy Inference System. This is also same, but here what is the condition? Your antecedent is fuzzy, okay, and your consequent also fuzzy, but your fuzzy form with monotonic membership function. Okay, so monotonic membership function means either it will be looks like this or it will be something like this. This will be a monotonic membership function. So in this, consequent of each fuzzy set will be represented by a fuzzy set with monotonic membership function. As the requirement of this model is a special kind of membership function, that's why it is not useful as a generalized average, but it can be used in some specific situations. Okay, so the procedure will be same. Say this is x is a1 bar and y is something like this b1 bar. So I got z as a consequent c1 bar, but that has to be in monotonic form like this. Then next rule says that suppose if x is a2 bar, y is b2 bar, then your z will be c2 bar but in monotonic form. Okay, and introduce the change. Suppose this is x1, this is y1, this is x2, this is y2. Okay. And do the max min. So you got it, this max. From here also this max, and select intersection from it. So this will be your intersection. From that you will get this is alpha 1, somewhere this is z1, here also some x2, here also some y2. Take it the minimum, from where you will get some alpha 2 with z2. So now if you would like to get the resultant crisp value, so what can be done? Again, I know alpha 1 z1 from here and alpha 2 z2 from here, so I can take it the minimum z1 plus z2 by 2 and I can find out the crisp value, or best way to use the weighted average approach here. So alpha 1 z1 plus alpha 2 z2 upon alpha 1 plus alpha 2. Okay, so this way you can use the different fuzzy model and can design the system. Mostly people are using the Mamdani Fuzzy Inference System to design the fuzzy system. Okay. Now with this, let us see one design of the fuzzy logic controller based on the thing which we have been studied. Okay. So here we will take the example of washing machine. Okay, so here I have to design the washing machine in such a way that the wash time should be appropriate according to the condition of your clothes. Okay, if clothes are very dirty and it is having high level of grease, then what may happen, your wash time will be more than that of the low dirt and low grease. Okay, so now my aim is, if some clothes are having some degree of dirtiness and mudness, then what will be the amount of wash time to take it to wash the clothes. Okay, so problem is clothes are dirty and muddy, or I'll say it contains grease. So if this is the situation, then I would like to obtain how much is my wash time. Okay, so now from that, in order to design the fuzzy logic system, first thing is to identify inputs and output variables. Once I know the inputs and output variables, then what next? Convert it into edges, or decide the edges, or descriptors or linguistic variables. Then you form the rules, then evaluate the rules either using Mamdani, Sugeno or Tsukamoto, and once you evaluated the rules, use the defuzzification. Okay, so here what are the variables? First variable is represented with dirt, mud and third is wash time. So this let me represent with X as a universe of discourse. Mud or grease let me represent with variable Y as universe of discourse, and wash time let me represent with Z as universe of discourse. Okay, so from that we know now what are the consequences and what is the output. So antecedent and what is the consequent. So what are the antecedents here? One is dirt, second is mud or contains grease. Okay, mud let me express in the form of grease. Okay, so these are my two antecedents, and let me represent with universe of discourse S. This may represent with universe of discourse Y, and third is your wash time, and that already we have represented with universe of discourse as Z. Now let us form the hedges, or let us decide the hedges or descriptors. So for dirtiness I'll represent with three descriptors or three edges. Let me call low, medium and high. Similarly for mud also, let me represent with three variables or three descriptors, so called low, medium and high. Similarly wash time as a variable, let me represent with very small, say small, medium, high and very high. Okay, so with this information, let us define the membership function for first inputs, and then if situation will come, we'll define the membership function for output, that is your wash time. Okay, so let me use the triangular membership function here. So to define this dirt, let me draw the membership, or let me express in terms of membership functions. So this is universe of discourse X, this is membership function, let's say mu d of your X. D stands for dirt. So suppose this is 0, 50 for mid and 100 for high. So this is I can consider 0%, 60%, 100%. Okay, so this will be one membership function, that is low dirt, and obviously maximum will be 1. This mud, which is medium dirt, let me represent with this 50 to 100, and for high dirt let me represent like this. Okay, so this is one fuzzy set which will represent mu LD, that is low dirt. This is your next fuzzy set which may represent with medium dirt, and this is your third fuzzy set, let me represent with high dirt, and all universe of discourse will be X, X, X. So this is a graphical representation for this dirt. Similarly, let me represent for next universe of discourse called mud, and I will use the same form in triangular fashion, that is 0, 50, 100. So if it is 0 to 50%, it is low mud, medium mud represent with 0 to 50 and 50 to 100, and high mud represent with 50 to 100. Okay, so this is the fuzzy set for low mud, this is the fuzzy set for medium mud, and this is the fuzzy set for high mud. and what will be universe of discourse here? Y, y, y. And now let me write its mathematical representation for each fuzzy set. So what will be for low dirt of x? It will be for this. Okay, so what is slope? Slope is minus 1 upon 50, and if you compute the y-intercept, it will be minus x plus 50 upon 50, and this will be valid from 0 to 50. Okay, x will be 0 to 50. Now next, let me write for medium dirt. So it will be simply x upon 50 from where to where? 0 to 50, and for this it will be x minus x, because slope is negative, plus 100 upon how much is the x2 minus x1? 50. Okay, so it will be minus x plus 100 upon 50 when your x vary from 50 to 100. Similarly, high dirt of x will be this thing. Okay, so which will be x minus 50 upon 50, where x will go from 50 to 100. Okay, so with this you can write similarly for mud also. So low mud, but universe of discourse will be simply y, so it will be 50 minus y upon 50, where y will be from 0 to 50. Next will be medium mud for y, it will be y upon 50 when y is varying from 0 to 50, and it will be minus y plus 100 upon 50 when y will vary from 50 to 100. Similarly, it will be high mud. For this it will be y minus 50 upon 50, and when it will vary y from 50 to 100. So this way you can represent the membership functions. Now next, what we will form the rules. Okay, and we have already discussed how to form the rules. So now there are two antecedents, so what I'll do, I'll make it one table like this. Okay, and suppose this is my x, which will represent dirt, and this is my y, which will represent mud or grease. Okay, and if these are the situations, then how many combinations I'll get it? I get it such kind of combinations, because x I have been expressed into three edges, so it will be low dirt, medium dirt, and high dirt. Similarly, it will be low mud, medium mud, and high mud. Okay, so with this, how many combinations? 9 combinations I get. So if I am making the rules now, if cloth is having low dirt and low medium, then I will say that okay, my wash time is very small. Okay, now that depends on us how to form the rules. Okay, so if x or dirt is low and mud is medium, then I will define that okay, my wash time is medium. If dirt is low, mud is high, then I will say that my wash time is large. If dirt is medium, mud is low, I will say that okay, my wash time is small. Then dirt is medium, mud is medium, then I will say that okay, my wash time is medium. If dirt is medium, mud is high, I will say that okay, my wash time is large. Similarly here, low mud and high dirt, let me say my wash time is medium. Say high dirt, medium mud, so let me say wash time is large. and for high dirt and high medium it will be say very large. Okay, now let us evaluate the rules by Mamdani model. So next will come as a rule evaluation. So let me introduce the change here. Now suppose x1, which will be a1 bar like this, what we have seen. So let me say that dirt, if it is 60% or 60 and mud is 70 or 70%, and then what will be wash time? How much is wash time? Okay, so I'll say that dirt, if it is 60 and mud is 70, then how much is wash time? That I have to find it out here. So in this I have to select the membership function, which will come under 60 and 70. So if you look at this, the membership function which we have been defined, so 60 is coming for medium dirt as well high dirt, as well as medium mud as well as high mud as a 70. Okay, so what will be the medium dirt membership function? It is 100 minus x upon 50. What will be the membership function for high dirt? It is x minus 50 upon 50, which will be varying from 50 to 100. Okay, that we have written from here. Okay, 50 to 100, it is minus x plus 100, and 50 to 100, x minus 50 upon 50. Okay, similarly you can write for medium mud, which is for universe of discourse y, and it is also same 100 minus y, except the variable 100 minus y. High mud for universe of discourse y, it will be y minus 50 upon 50, and here y will vary from 50 to 100. Now just evaluate for dirt is equal to 60 and mud is equal to 70. That is what Mamdani, right? So this is already one fuzzy set like this, same MD. This is high fuzzy set, which is dirt, so I will get it some wash time. Okay, similarly here also y. Now introduce dirt as 60, so somewhere here in this also dirt will be somewhere here, so you have to find it out how much is the membership value. Okay, so you just put it, x is equal to 60 here and y is equal to 70. So how much will be mu md for this x, which is 60? It will be 100 minus 60 upon 50, so which is 4 by 5. Similarly find out the value for HD at dirt 60, which is 60 minus 50 upon 50, which is 1 by 5. Similarly for mud, so my for this 70, no? Y will be 70, so it is 100 minus 70 upon 50, which is 3 by 5. Similarly high mud, yeah, y will be 70 minus 50 upon 50, which is 2 by 5. That also I know it now. Okay. Now what I will do, I will next form the rules. So how many rules will be there? Now there will be 4 rules for this dirt 60 and grease 70. Okay, so what will be rule 1? It will say that if dirt is medium and mud or grease is medium, then what is the wash time? Then wash time is how much? Already we have formed that. So for dirt medium, grease medium, this is medium as a wash time. Okay, this one. Okay, so if dirt is medium, grease is medium, wash time is medium. Next rule I can form: dirt is medium, grease is high, then wash time will be large. Because for 60 and 70, what I got it medium and high. Okay, so one time I will take medium dirt, medium mud, medium dirt, high mud, high dirt, medium mud, high dirt, high mud. So what will be the wash time? If the dirt is medium and grease is high, then wash time will be large. If dirt is high and grease is medium, then my wash time is large. If dirt is high, grease is high, wash time is very large. Okay, so now these three rules are applicable for this given change. Okay, so next second rule I will write: if dirt is medium and mud is high, then wash time is large. Here wash time is medium. Then third rule I will form that if dirt is high and mud is medium, then my wash time will also be large. And similarly, rule 4 I will say that if dirt is high and mud is also high, then what will be my wash time? Will be very large. Now for this I have to define the membership function for this wash time. So let me define the membership function randomly. Let me take it and let me represent with triangular membership function. As I am using Mamdani, so again your consequent has to be in fuzzy form. Okay, so suppose this 0 10 minutes wash time, so it is in minutes, obviously it is 40, and suppose this is 60. So 0 to 10 I will say very small, I will say 0 to 10, 10 to 25. Medium I will say is 10 to 25, 25 to 40. Large I will say 25 to 40 and 40 to 60, and very large I will say up to 40 to 60. Okay, so this is Z with wash time for this Z. Okay, so that mathematically also I can write it will be wash time for very small. So very small for Z will be this much, is how much? 10 minus Z upon 10. So it will be minus Z plus 10 upon 10. It will be valid from 0 to 10. Then this is very small, this is the fuzzy set for large, this is the fuzzy set for medium, this is the fuzzy, this is fuzzy set for small, large, and this is the fuzzy set for very large. Okay, so for small, what it is Z upon 10 from varying Z between 0 to 10, and it is minus Z plus 25 upon 15. Okay, 25 upon 25 minus 10, it will be 15. So minus Z plus 25, it is valid from 10 to 25. Then for third fuzzy set, let me write for medium. So this will be, medium will be Z minus 10 upon 15, and 10 Z will vary from 20 to 25, and it will be minus Z plus 40 upon 15, and Z will vary from 25 to 40, and large will be Z minus 25 upon 15, where it will vary from 25 to 40, and from 40 to 60, what it will be minus z plus 60 upon 60 minus 40, it will be 20. And for very large, it will be simply z minus 40 upon 20, where z will vary from 40 to 60. Okay. So that way we have also defined the membership function for wash time. Okay. Now let us evaluate quantitatively. So for rule 1 says that medium mud coupled with medium dirt coupled with medium mud. Okay. So it is AND operation. So if it is AND, means it will be a minimum from mu md of x with mu mm of y. Okay. So how to calculate that, which will be selected as minimum, because we are using minimum as an operator, or this is basically coupling. So take it the minimum from mu md of 60, because where we are applying for 60 and mu mm for 70, that already we have evaluated. Mu md of 60 is 4 by 5 and mu mm of y is 3 by 5. Okay, so 4 by 5, 3 by 5, minimum is 3 by 5. So which will be minimum 4 by 5, 3 by 5, which will be 3 by 5. Similarly, R2 says that medium dirt with high mud. So again here do the intersection. So it will be mu md of 60, mu high mud of 70, and mu md of 60 is 4 by 5, and mu hm of 70 is 2 by 5. Okay. So select minimum from it. So minimum will be 2 by 5. From rule 3, rule 3 is what? High dirt with high mud. High dirt with medium mud, for example. So here also do the minimum. So it will be mu high dirt of 60 and mu medium dirt of 70. So it will be mu hd of 60 is how much? Mu hd of 60 is 1 by 5, and it will be 3 by 5. So it is 1 by 5 and 3 by 5. So select minimum, which is 1 by 5, and let us evaluate for rule 4. So which will be high dirt with high grease or high mud. So take the minimum from hd from 60 and hm from 70. Okay. So which will be hd for 60 is 1 by 5 and hm for 70 is 2 by 5, which is 1 by 5. And all the rules, now what has to be done? Aggravated or augmented. And if it is augmentation, means it is the ORing. ORing means selecting maximum. Okay, so you select max from all the 4, which is 3 by 5, 2 by 5, 1 by 5, and 3 by 5, 2 by 5, 1 by 5, and again it is repeated as 1 by 5. And from that, which one will be maximum? Maximum will be 3 by 5. So this 3 by 5, which it corresponds to rule 1. Okay, and for this 3 by 5, I can select my wash time. So what I am getting this corresponding maximum as for medium dirt with medium mud, and what this rule says that if it is medium mud and medium dirt, then your wash time should be medium dirt and medium mud, then wash time should be medium. Okay, and we have defined the wash time for medium is z minus 10 upon 50 and 40 minus z upon 15, so that you can substitute here. So this is simply defuzzification. See, very simple. This is all in fuzzified form. Now we have to do the defuzzification, and for 3 by 5 I know correspondingly it is coming under rule 1. So this is corresponds to medium wash time, and for medium wash time, what is it? Z minus 10 upon 15 is 1, which will be coming as 3 by 5, and second is 40 minus Z upon 15. This is also 3 by 5, because for medium I am getting the two fuzzy sets, and from that you can evaluate Z. So here Z, if you evaluate, you will get 90, and here you will get Z is equal to 31 seconds or minutes. Now I am observing here that all crisp, these are my crisp values. Okay, so I am getting two values. So what I can do, I can take it, the average, which will be 19 plus 31 divided by 2, and approximately it may be 25 minutes if I am taking the average method. Okay, you can use any other defuzzification method, you will get it the small change in these values, maybe 27 minutes, maybe 28 minutes, like this. And this is what you have been achieved the accuracy in uncertainties, because I don't know how much percentage of dirt is, how much percentage of mud is, but still I am estimating, okay, that 25 minutes may be the wash time if your dirt is medium and if your mud is also medium. Okay, so that way you can do quantitatively. Also, if it is graphically, you can also see that with the representation of triangular membership function. Okay, that is 0, 50 and 100. So what was for a dirt? Dirt was for if dirt is medium, then mud is also 0, 50 and 100. This is also medium. Then what will be wash time? So it is between where to where? Wash time is medium, so it is between 10, 25, 40. So it will be 10, 25, 40. Okay, so something like this. This is the rule 1, and now for rule 2 also you can say same, that is one is, this is medium, but now this is high. Okay, 50 to 100. Then what is the wash time? You can plot that. So this wash time is large, and large it is saying 25 to 60, 25, 40, 60. Okay, so it is 25, 40 and 60. So you can represent it this way. This is rule 2. Again similarly, rule 3, what it says, if dirt is high and mud is medium, then it is also, I think, large. If dirt is high, mud is medium, it is large, means large is between 25 to 60 with same thing here. $25, $40, $60. Okay, now next rule, what it says, fourth rule, it says that if dirt is high, mud is also high, then your wash time is very large, that is 40 to 60 and something like this. Then what to do, now introduce some small change. So you take it 50, 60 here, so this will be 1, 70 here, this is 1, and then taken the minimum. Already we have done the minimum. Okay, somewhat here 3 by 5, 1 by 5, and then we have projected on it, so we have calculated this value. Okay, similarly here also, this was 50, this was something 70. From here also minimum I have taken. Okay, from here also this is 60, this is 70, so from here also minimum we have taken, and here also this is 60 and this is 70, here also minimum we have taken. So what are the values? 4 by 5, 3 by 5. So from here I got, this was 3 by 5, this was maybe 4 by 5. So from here this was 4 by 5, this was 3 by 5 something, you select correspondingly. So minimum was, I got 3 by 5 here. If you plot properly you will get the correct results. 3 by 5. Next for that 2 by 5, minimum I got 2 by 5. Okay, so here 2 by 5, here somewhat 1 by 5, and here also 1 by 5. Okay, so this was around 3 by 5 somewhere, 2 by 5, 1 by 5, and this was also 1 by 5. Okay, and then select the maximum for this one. So maximum will be obviously for coming under 3 by 5, and this actually I would like to calculate it. Okay, and from that we obtained something, because here is also cutting and one more here is also cutting, so I am getting 2 points here, and I am taking the minimum, so this will be around like this. Okay, so I am taking the maximum, that's why we have taken the maximum from 2, 3 by 5, 2 by 5, 1 by 5, and 1 by 5. I got 3 by 5. So for this membership value 3 by 5, I will get it 2 points here. So I got it 2 points, and then take it the average. Okay, or you can call Z1 into this plus Z2 into this divided by Z1 plus Z2, or this plus this, that also weighted average also you can do it. Okay, but just for understanding I have taken the minimum, so that I am getting this this much is wash time. Okay, so with this I'm going to stop here. Now next class we will try to see its Python implementation. Okay, fine. So thank you very much.